Dear students, welcome back, and the topic of this lesson is again arc length. And in our previous lesson, part 1, we used formula 1 and formula 2 to calculate arc length of a given curve like y equal to either function of x or x equal function of y to calculate arc length. But here in this lecture we want to use formula 3 in order to calculate arc length of some problems like problem 1 to 8. And note that formula 1 and 2 was integrating with respect to x and integrating with respect to y, but formula 3 is related to the parametric equations. Here t is a parameter and the integration is on t. You need to integrate with respect to the parameter. Here you also need to note that the derivative dx dt and dy dt need to be continuous on this interval a to b. So now let us try to solve some problems using formula 3, and here we have 8 problems. We want to solve these problems in this lecture, and it says find the let us solve the first one. It says find the arc length of the following curve where x equal to 1/3 t cube and y equal 1/2 t square and t lies from 0 to 1. So since the given curve is related to the parametric equation, so our arc length formula will be the third one, which is L equal integration from t equal a to t equal b square root of dx dt square plus dy dt square dt. So first we need to calculate dx dt and dy dt. Since x equal 1/3 t cubed, so dx by dt will be 1/3 3 t square, which is equal t square, and dy by dt is equal, since y equal 1/2 t square, so dy by dt equal 1/2 into 2t, which is equal t. So now we can use our formula L equal, and t is given here from 0 to 1, so the lower limit will be 0 and upper limit will be 1 square root of dx dt, which is t square whole square, plus dy dt, which is t dy dt whole square dt. So now you can easily integrate it by yourself, but let me help you. Dt, which is equal 0 to 1, you can take t square out of this square root, so we will get t square will be t root t square plus 1 dt. Now by using u substitution we can easily integrate it. Let's say t square plus 1 equal to z, so 2t dt will be dz and t dt will be dz by 2, and the value will also again change when t equal 0 and 1, then z equal, when t equal 0 z equal 1, and when t equal 1 z equal 2. So this integral becomes 1 to 2 root z and t dt t dt equal dz by 2. So I can write dz by 2 here, which is equal half. Integration of root z will be z to the power 3 by 2 divided by 3 by 2, 1 to 2. This equal half into 2 by 3 z to the power, instead of z I can write 2 to the power 3 by 2 minus, if I put lower limit it will be 1. So this equal 1/3, and 2 to the power 3 by 2 I can write 2 root 2 minus 1. So this is the answer. So now let us try to solve problem 2, and here x equal 1 plus t square and y equal 1 plus t whole cube. So let me first calculate dx dt. Dx dt will be 2 times 1 plus t, and dy dt will be 1 plus t whole square. And let me calculate the addition of their square. Dx by dt whole square plus dy by dt whole square, which is equal 1 plus t square. If you square it, plus if you square this term it will get 9, 1 plus t whole to the power 4. And our arc length formula is this, and here t again 0 to 1, so 0 to 1 square root of 4 into 1 plus t whole square plus 9 into 1 plus t whole to the power 4 dt. So how can we integrate it? We can do the u substitution here. 1 plus t, let's say u, then dt equal du, and when t equal 0, u equal 1, when t equal 1, u equal 2. So this integral becomes 1 to 2 square root of 4 u square plus 9 u to the power 4 du, because dt equal du. So now we can take this u square out of this square root, so it will be u root 4 plus 9 u square du. Again we can do the z substitution here. Let's say 4 plus 9 u square equal to z, then 18 u, derivative of 9 u square, 18 u equal 18 u du equal dz. So u du will be dz by 18, and when z equal 1, u equal 1, u equal 1, z equal, when u equal 1, z equal 13, and when u equal 2, z equal 2, so it will be 36 plus 4, 40. So this integral now becomes 13 to 40, and u du equal dz by 18 root z. So this equal 1 by 18, and integration of root z, z to the power 3 by 2 and 2 by 3, let me write here 13 to 40. So the answer will be 1 by 27. If we put 40 here, it will be 40 root 40, since x to the power 3 by 2 equal x root x. So 40 to the power 3 by 2, 40 root 40 minus 13 root 13. So this is the answer. So now let us solve example 3, and here x equal cos 2t, y equal sin 2t. So dx by dt will be minus sin 2t, and the derivative of 2t is 2, so 2 sin 2t, and dy dt will be derivative of sin 2t, which is 2 cosine 2t. So now we can square these two terms and add, or let me write it directly in the formula. So t is from 0 to half, so 0 to half, 0 to pi by 2, square root of dx dt whole square minus 2 sin 2t whole square plus dy dt whole square 2 cos 2t whole square dt. So this equal pi by 2, and the square of this one is 4 sin square 2t plus 4 cosine square 2t square root dt, and this equal, if you take 4 here, then we have sin square 2t plus cos square 2t, and which is 1. So we have root 4 0 to pi by 2 dt, since sin square 2t plus cosine square 2t equal to 1. So square root of 4 equal to 2, 0 to pi by 2 dt, which is equal to times 0 to pi by 2, which is equal to 2 into pi by 2 minus 0, which is equal pi. So pi is the arc length of the curve given by these parametric equations. Now let us try example 4. And here x equal cosine t plus t sin t. So dx dt is equal derivative of cosine t minus sin t, plus we can use product rule here. So the first one will be t derivative of sin t, which is cosine t, plus sin t derivative of t, which is 1. So we have only sin t, and sin t will cancel. So we have t cosine t, and again from here dy dt is equal derivative of sin t cosine t minus, we can use again product rule here. So t times derivative of cosine t, which is minus sin t, plus cosine t times t derivative of t, which is 1. So cosine t plus t sin t minus cosine t, this one and this one will cancel. So we have t sin t. Now we can calculate their addition of their square, plus dy dt it should be dt whole square is equal t square cosine square t plus t square sin square t. So the answer will be t square, because cosine square t and sin square t equal to 1. So the arc length formula L equal t is from 0 to pi. So this is the solution of 4, 0 to pi, square root of the square, this one and this one means t square dt. So we have only t, and the integration of t equal t square by 2, 0 to pi. So if you put the upper limit, we have pi square by 2 minus 0, this equal pi square by 2. So now let us try problem 5, and here x equal et cosine t, x equal e to the power t cosine t, and y equal e to the power t sine t. So we need to calculate dx dt, and we can use product rule here again. So e to the power t derivative of cosine t minus sine t plus cosine t times derivative of e to the power t, which is e to the power t. So this equal e to the power t minus e to the power t sine t plus e to the power t cosine t. And again dy dt is equal, we need to use product rule. So e to the power t cosine t plus sine t e to the power t. Now we need their square term. Let me do it here. Dx by dt whole square equal a square a plus b whole square. So a square means square of this term, which is e to the power 2t sin square t plus square of this term e to the power 2t cosine square t minus 2ab. So 2 e to the power t times e to the power t, which is e to the power 2t sin t cos t, sin t times cosine t. And again dy by dt whole square is equal square of this term e to the power 2t cosine square t plus square of this term e to the power 2t sin square t plus 2ab. So 2 e to the power t into e to the power t e to the power 2t sin t cosine t. Now if we add dx by dt square plus dy dt whole square, if we add these two, then this term and this term will cancel. So we have 2 e to the power t sin t, you see, and 2 e to the power t cosine square t. So we have 2 e to the power 2t sin square t plus 2 e to the power 2t cosine square t, and which is equal to e to the power 2t sin square t plus cosine square, and this one equal to 1. So we have finally 2 e to the power 2t. Therefore the arc length L equal integration from 0 to pi by 2, 0 to pi by 2, the square root of this term, which is 2 e to the power 2t dt. This equal root 2 will go out from integration root 2 integration of 0 to pi by 2 and e to the power 2t, the square root of e to the power 2t, which is e to the power t, e to the power t dt, and integration of e to the power t is equal e to the power t 0 to pi by 2, which is equal root 2 e to the power pi by 2 minus e to the power 0 equal to 1. So this is the arc length. So now let us try to solve example 6. Here x is this. So we can calculate dx dt by the product rule, and let's say this is u and this one is v within the first bracket. So e to the power t derivative of sin t plus cos t plus sin t plus cos t derivative of et, which is equal e to the power t derivative of sin t cosine t minus plus derivative of cosine t minus sin t plus derivative of e to the power t e to the power t. So I can write e to the power t sin t plus cosine t, and you see e to the power t sin t is negative and e to the power t sin t is positive here, so we can cancel it, and we have e to the power t cosine t e to the power t cosine t. So we have 2 e to the power t cosine t, and similarly we can again calculate dy by dt from here. So it will be et derivative of cosine t minus sin t minus derivative of sin t cosine t plus this one, because et derivative of et e to the power t, so it will be exactly same minus sin t, and here we have minus e to the power t sin t minus e to the power t cosine t plus e to the power t cosine t minus e to the power t sin t. So we can cancel this two term minus 2 e to the power t sin t. Now we can square and add dx by dt square plus dy by dt square is equal, if you square this term you will get 4 e to the power 2t cos square t plus 4 e to the power 2t sin square t, and which is equal 4 e to the power 2t, since cosine square t plus sin square t equal to 1. So our arc length L equal integration from 1 to 4 square root of this term, and this term means 4 e to the power 2t dt, which is equal integration from 1 to 4. So this 4 will be 2, and the square root of it to the power 2t e to the power t dt, which is equal to integration of e to the power t e to the power t. So 1 to 4, and this equal to e to the power 4 minus e. So this is the answer. So now let us try to solve example 7, and here x equal 1 plus 3t square and y equal 4 plus 2t cube, and t is from 0 to 1. So first calculate dx dt, which is equal 0 plus 6t, this is 6t, and dy dt equal 0 plus 6t square, which is 6t square. Therefore arc length L equal t 0 to 1, 0 to 1 square root of dx dt whole square. So 6t whole square plus dy dt whole square, 6t square whole square dt, and which is equal 0 to 1. This one 36t square plus 36t4 root dt, and we can take out of the 36 from this square root, so it will be 6. Even we can write out of integration 0 to 1, and at the same time we can also take t square, so it will be t root 1 plus t square dt. Now we can use z substitution, 1 plus t square equal to z, so the 2t dt equal dz, therefore t dt equal dz by 2, and the value of t will also change. When t equal 0, z equal 1, t1 gives z equal 2. So this one will be 1 to 2 root z and t dt, which is dz by 2. Okay, dz by 2. And now this half we can take out of this integration, it will be 3, and integration of root z, z to the power 3 by 2 divided by 3 by 2, 1 to 2. Now we can write 3, 2 by 3, 2 root 2 minus 1. So this equal 2 times 2 root 2 minus 1. So this is the arc length of the curve given by the parametric equations in problem 7. Now let us try to solve example 8, and here x equal e to the power t plus e to the power minus t, and y equal 5 minus 2t. So dx dt is equal derivative of e to the power t, e to the power t, and e to the power minus t minus e to the power minus t, and dy dt, which is equal 0 minus 2, which is equal, so t is from 0 to 3, 0 to 3, dx dt t e to the power t minus e to the power minus t whole square plus minus 2 whole square root dt. This equal 0 to t, square root of this will be e to the power 2t minus 2 plus e to the power minus 2t plus minus 2 square 4 square root dt. This equals 0 to 3 e to the power 2t plus 2 plus e to the power minus 2t square root dt, and this one is nothing but square root of e to the power t plus e to the power minus t whole square dt. Now we can cancel this. So we have 0 to 3 e to the power t plus e to the power minus t dt, and this equal integration of e to the power t to the power t minus e to the power minus t, 0 to 3, which is equal e to the power 3 minus e to the power minus 3 minus e to the power t equal e to the power 0 equal 1 minus 1. So the final result will be e to the power 3 minus 1 by e to the power 3. So this is the arc length of the curve given by the parametric equation in example 8. So that's all for this class, and hope you enjoy the class and hope to see you in the next one. Thank you very much.